GM, welcome to another week of hard work. Somebody who is like a mentor in the field used to say, a new week, another opportunity to be world class. So in our pursuit of excellence, that's what brought us to this class today. Last class, you were taught custom types, error handlings, right? I think the last tutor mentioned structs being a type of custom data type or complex data type in Cairo, and enums too, also a data type, as well as error handling. If you could remember in my class, I said Cairo is basically used for two things: provable programs and Starknet smart contract. We'll be diving into Starknet smart contract today. You guys are not unfamiliar with smart contracts. You have written tons of them in Solidity, right? So smart contract is basically what you know it to be. Something that is transparent, that is going to do exactly what the developer says it is going to do. Whatever the developer says it is going to do is left to the developer. It doesn't mean because it's a smart contract, it is what? Foolproof and fault-proof. It is simply what the developer says the smart contract should do. It can be fraud. So that is why you need to understand smart contract to be able to read other people's smart contracts, analyze it, and determine whether it is going to do exactly what you, not the developer, are expecting the smart contract to do. If I tell you today, I have a smart contract that will double your money, and I expose the client a website, just click button, save money, and withdraw double. As a smart contract developer, the duty is on you. The obligation is on you to go and check or ask, where is the smart contract? And go and check if the logic of the smart contract is actually going to double your money. If when you go to this particular smart contract, you realize that, no, this smart contract will not double my money. It will take it. And I will never get anything back again. You realize that, yes, you have taken a step ahead of every other person in the world who doesn't know how to read, analyze smart contracts. So as a developer, your goal is to write smart contracts that are error-free and that are going to do what the users are expecting the smart contract to do. For Cairo smart contracts, we have different moving parts that makes a smart contract. The first one is actually the declaration of the smart contract itself. Unlike Solidity, where you first have the license identifier, the top line, your imports, next after that, and the rest. What actually signifies the beginning of a smart contract, is the smart contract attributes. I talked about macros in my last class and how they are actually code abstractions, meaning that you will see a line of macro, but when your code compiles, it is going to output a numerous line of what? Code. So to start a Starknet smart contract, we have the external attribute Starknet contract. Without this, you do not have a smart contract. So if I will be giving you an objective question and say, how do we start a smart contract? I can tell you, you just shout smart contract, option A. External attributes, option B. Module declaration, option C. You realize that, okay, for you to start a smart contract, you need the external attributes. However long a smart contract is, the beginning of that smart contract is the external attribute. We will see this in action in different smart contracts, no matter how complex the smart contract is. If there is no external attribute smart contract, the smart contract is never a smart contract. It is basically whatever you call it. On smart contracts. Look at this. These are particular projects. You see all of these high distributor types, errors. They are like supporting code for a smart contract. All of them are useless currently. If there is no smart contract utilizing the code inside there, and which is here, distributes. If you look at this distribute, we started with what? Starknet contracts. So that is basically how you start a contract. It marks that this particular module we are writing is what? A contract. You declare it with a public or pub keyword. And it means this code, inside this code block, is the code that is actually our smart contract. The code inside distributor is what? Is our smart contract. Do you have any question on that? Something outside of what you understand? I know a lot of you already know this, but maybe there's something you've been meaning to ask somebody. You know, it's a different thing when you are writing contracts because you just know how to write it, and then another thing when you really want to know what is going on. Do you have any question on how we come to say, okay, how is an external attribute declaring the beginning of a smart contract? What if we do not have the smart contract attribute, the Starknet contract attribute? What happened to that particular module? It is just an ordinary module. So after you have done, I'm just trying to show you how the component of a smart contract is before we move into detailed explanations. So after you are done declaring your smart contract module, conventionally, what is next is just your imports. Import of dependencies, meaning that there are some of these functions here, some of the code here, that we now need to use. We need to use them in the smart contract by actually bringing them into scope. So this is what is known as scope. From this curly bracket, okay. From this curly bracket to the corresponding closing one, everything inside it is the scope of the smart contract. So bringing them into smart contract, we use the keyword use. Use, when you see core, this particular program is actually Starknet's core program, core code. Are you following? Starknet core code. When you see special name, like fundable, it either means two things. Either you are actually referring to the name of the package itself or the name of an imported external dependency. Are you following? And you know how to import dependencies, right? In your scarp.toml, we have dependencies here. So FP, Open Zeppelin, and Starknet, they are external dependencies. So we brought them into scope here. See Open Zeppelin. Fundable is the name of the package of this particular contract or crate we are working on. Look at it here. Are you following? The entry point of the particular
that it is involved is main.rs. What the entry point is your smart contract?
Smart contract does not have an entry point.
Then what about the lib.carry? What is it meant for?
It is actually meant for you to expose different programs. For example, let me show you the libs.cairo. So when you say entry point, I'm assuming you are talking about how people interact with the smart contract, right? Not how you write the code. For example, in the provable program, the main.cairo is the entry point. You must have a main function. Are you following? A main function is the entry point of a provable program. But for Cairo smart contract, there is no entry point. The only thing is that this lib.cairo is like the original scope of your Cairo. We are assuming that, okay, two things. There can be executable files and there can be library files. Are you following? Library files are meant to serve as either packages for other executables. Executables in Rust are the ones that have main.rs, right? While library packages are the ones that have what? lib.rs. A Starknet smart contract is a library, not an executable. That is what differentiates it from a provable program. A Cairo provable program will only have main.cairo. Are you following? So this is what makes Starknet smart contracts a library. You need the lib.cairo first. From here, you can now determine or define all the modules that you want to be inside this particular library. Inside this library now, if we are talking about hierarchy now, we'll say we have, I thought I saw the marker somewhere. Okay. So let's say this is an hierarchy, right? The next is, according to what is on the screen, base.cairo, blah, 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 blah. So, but the top of the hierarchy is the lib.cairo. If you wish, you can decide that all of your code, without branching out for organization, will be inside your lib.cairo. It is going to work. But the lib.cairo must be present. Are you following?
Yes, sir.
So here, because of organization, we decided we need different modules. We have base, we have distribute, we have interfaces, we have payment stream, and USDC. But back to our original talk, once you decide that, okay, I have declared my contract, you know what you need to use to make your contract, what you need to use to write effectively. You bring them into scope. You use the use keyword to bring what you need into scope. I already mentioned this is actually Starknet's core Cairo what? Core Cairo packages. Are you following? This is Starknet's package. This is OpenZeppelin code. And this is actually code that we wrote in our own package. So instead of mentioning the name, you can as well use crates. Are you following? You can as well use crates to actually refer to code that you write inside your own library. Talking about import, right, of dependencies. So these are dependencies, core libraries, external libraries, interfaces, and the rest. We also have what is known as components. In a subsequent class, you are going to dive deeply into components. Off the top of my head, or an overview of our components, it's like an abstraction. You know what is called as don't repeat yourself, right? Dry concept of coding. Don't repeat yourself. Meaning that if there are functions that you feel like you will use a lot, write it somewhere, especially if it is TypeScript, you can write it in a util file, import it everywhere you need it. It's the same thing with smart contracts. There are standards that must be used, especially when it comes to ERCs. ERC 20, there are standards. ERC 725, there are standards, right? So what if somebody has written an industry-accepted ERC 20 smart contract, and every of us can reuse it anywhere we want to write our Cairo contract? How do we do that? In Solidity, we inherit, right? We inherit the contract that this person has written to be able to use it. In Cairo, we use components. We use components. You are going to dive into components in a subsequent class. I think maybe the next 3 classes you'll be doing components. So what makes a component, how you can actually make your code reusable and composable. You do that in component. So this component macro is basically telling us that we are bringing into scope too some components for reusability. We are bringing into scope upgradable components and ownable components. Is there any question before I proceed? It is all clear?
I think that you imported most of the package into this distribute.camel. What is that mean?
Yes. Once you import them, they are already in scope. Until you need what you import in the execution of in the implementation of your smart contract before you use it. But if they are not in scope, you cannot use, for example, you look at these errors now from the error module, right? We have empty recipients, array len mismatch, and the rest. We cannot go and propagate error with array len mismatch while it is not in scope.
But from your code base that I can see, most of your functions are being performed in this your distribute, right? This is just like a main entry point of your code.
Sorry, rephrase that question.
So now, from your code base now, this your distribute file that is there. You imported most of the component into it. So now, for the component, it seems like this your distribute is just like the main entry point of your smart contract.
Yes. No, I still do not get the main entry point of the smart contract.
They're making use of most of the components in it.
Yes.
So I think just that the main entry point of it. Then the that because I might expose everything. I don't know if you guess.
You said? Declarations of. Now, if I understand you correctly, you see entry point you are saying, right? I want you to expatiate or explain more. Okay. Entry points.
Scroll up to line 1. So you can see now you're making use of the use core and all the whole packages here. And this is your distribute.
Yeah.
For the look of things now, we perform most of the function in it, right? Mean that from my own point of view, I think it's your main entry point of the smart contract. I don't know if you get that. I don't understand this.
You see, I really want to understand you, but the entry point is confusing. The entry point for the users to use the smart contract, the entry point for you to write your smart contract, what exactly is the entry point here?
Okay, let me remove the entry point from it now. You see like most of your functions are being called inside this your distribute file. That means that most of the computation is done here. Right? That my own point of view, because the main entry point that is this.
Okay, the main entry point to the contract is this particular distribute contract. Yes, definitely. For example, your main entry point to all your contract will be inside your contract. Do you understand? You can have functions that are actually peripheral EPA functions outside of the contract. Are you following? But the main functions for your smart contract, what users are going to be interacting with, will be inside your contract module. If I understand what he's trying to say, or let me say if I want to give another opinion, maybe he's talking about interfaces, right?
Yes.
Yeah, interfaces is a different case entirely. You understand? We'll go to interface. You understand, right? We'll get to interface. But interface is a different case entirely. Interface is just like a representation of what your smart contract contains. The callable functions that you can interact with in the smart contract. Are you following? So that's what an interface, but your smart contract is more than your interface. It contains a lot of things. You can have internal functions inside your smart contract that the user will never interact with. Are you following? So where was I earlier? I said error, right? Inside your scope, I'm still talking about scope. Here it's like we are going to Abuja. We have reached Abuja Junction. Our journey is still far. Most of the questions that you have will be answered along the line. Are you following? So here is where I am currently. I'm talking about component, how you can actually make use of composable and reusable code inside your smart contracts. So how do you make use of them? You use the component macro, parts, you name the file you brought into scope. For example, we brought upgradable component into scope from the OpenZeppelin contract or code base. Then we declare it here. You need to actually, this is like a convention. Without following this convention, you will never be able to reuse composable contracts. Are you following? Without this convention, you never be able to. You need what is known as the path, the storage, and events. Is that taken? So just to rephrase or talk about what I've said earlier, components are reusable piece of functionalities. You have a function somewhere that you want to reuse, you turn them into components and be able to use them anywhere in any smart contract. The component macro declares a component and associated storage and events, just like you have seen in the code, the paths, the storage, and events. To actually now make a component function, to make it external, you understand that a user can interact with that same function. You use what is known as the ABI embed version 0 external attributes. For example, if we are using ERC20 components and you want users to be able to fetch the decimal of that particular ERC20 token, you actually now use ABI embed version 0 to make all the external functions that are in this component applicable to our contract. So once I deploy this particular smart contract, the interfaces that the users will be able to use will not be limited to what is in the interface of the smart contracts. Are you following? This is presumed the interface of the smart contract. If a user wants to learn what they can do with our smart contracts, they go to the interface, they see distribute. They see distribute weighted, right? They see get protocol fee percent and the rest. But once we have actually declared that our imported component can also be extended for external use, on the blockchain, what the users will see that they can interact with will go beyond what you see here. It will involve all the interfaces that are coming from our component too. Do you understand that? So, come on, let me show you a typical example. If you look at the interfaces declared here, and the interface you are seeing here, you will notice there's a slight difference, right? What's the difference here? There is something that is not declared in our interface. Owner. That you are seeing here. And it is basically because we extended the ownable components that we imported into scope. Do you understand that? Do you get it now? Yes. So basically, you you extend the interfaces of the component that you bring into scope by actually doing the external attribute ABI embed v0. The next most important part of a smart contract is known as storage. Can you have a smart contract without storage? Are you sure? Like it's a smart contract, but there's no storage. Really? Okay, what will you call a upgradable smart contract? Especially in Solidity, not in Cairo. In Solidity, when you are using diamond pattern of upgradability, right? What happened? You can have your storage in a separate smart contract and implementations in a separate smart contract. Meaning that in your implementation smart contract, there is no state. Are you following? But in Cairo, you need states. And the state is basically storage. So in Cairo, a storage, just like even in Solidity, storage is... No. In Cairo, storage is key value. When you say key value, it's just like the association. What's the key? What's the value? Name. TT. The name is the key. The value is the TT. Are you following? So every contract must have at least, not even at least, exactly one storage definition. You can't come here and say storage and then come again and say another storage, blah, 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 struct, storage, and then you go on and do this. Are you following? It is impossible. You can't do... In fact, you already see that the language server is telling us no. You can't have multiple storage. So you can only have one storage, and it is the persistent state of your smart contract. What do I mean when I said persistent states? What is the persistent state here? Persistent and state. State and capital. It basically just means after the execution of your function, the state will remain. Your functions can modify state, but the state will not disappear. Your storage will not disappear from your contract because you execute a function. Are you following? Your storage is persistent. You can modify the values inside the storage, but your storage is never going to disappear. This is the concept of, okay, when you say we have state variables, we have local variables, right? You know your local variables are going to actually become useless once the execution of your function is done, right? Yes. But your state variable will never become useless. That is the reason why when you deposit money into a vault, you do not come back next time and tell you it is now 0 unless you withdraw the money. If the storage is not persisting, then your money is gone. Are you following? So storage is a key value pair. The key is actually what you want to use to remember the value, depending on whatever you like. But the value must be types that are accepted in Cairo. The basic types, the compound or the complex types. And then there are actually other types like map and vec that you can use to store values in Cairo. For you to be able to use a compound type like struct, you need external annotation, starknet.store. I used to call it dot, but some people call it namespace. Yeah, I'm with you.
Is there a place to see all the attributes?
Is there?
A place to see like a resource to see all the attributes?
I think there is something like that in a Cairo book. But once you are learning, all you need to learn is actually provided to you at that moment you are learning it. For example, if you are learning about storage, right? So all you need to learn about storage will be provided, just like I'm doing here now, teaching you about storage and telling you if you want to use complex data, you need to annotate it with what? Starknet.store. You understand? But I'm not sure if there is a place where you can read all the external attributes. I'm not even sure if it is going to make sense for them to just list them without you seeing them in application. For example, look at this protocol matrix. It's a struct, right? And the struct has what is known as Starknet namespace store. This is what makes it easy for us to use this protocol metric as a storage value in our code. This is real-time code. This is not a counter contract. We will do counter contract, honestly. But when you learn, sometimes people learn differently. People learn from basic, then to complex. But when you see real application, real life stuff, then you begin to step down from there. You understand? To me, it is easier because unlike when you learn basic and then you are on your own and you become confused. How to move from point A to point B. Now, look at one of the values we are using in our storage, right? We are mapping a U256 to what? To distribution history. This distribution history, we are able to use it as a storage value because it is already annotated as what? Starknet namespace store. Without that, we will not be able to use distribution history. Storage feed can be primitive types, U256, U16, and what have you. It can be complex types, a map, and a vec, custom structs, contracts, addresses. Storage is persistent and can be read and written too. When you want to read a storage value, you only need to have the snapshot contract states in your function. Look at this particular function. This function is reading from our storage. It's reading a particular value, fee percent, protocol fee percent, right? We will not be able to do this if we do not have the self argument or self parameter, which is a what? A snapshot of the contract state. In that situation, we already know that a read function does not attract what? Does not attract gas fee. We are only trying to read what is there. Right? If a writer, well, some writer can charge you to read their book, but you are not permitted to modify their content. But you can see something on the street and just read it free of charge. But you cannot go to the printing press and tell them what they have done is wrong. They should rewrite it. They will tell you, where's money? So to read from a storage state, you only need the snapshot contract state. When you are writing smart contracts, there is not much flexibility. You need to actually follow conventions. I cannot come here and say, okay, no, I don't want to use contract states as the type of this self. Let me use something else. Maybe not contract state. Not contract state. Are you following? Yeah. So it will never work. Here I'm just demonstrating that as long as you do not need to memorize certain keywords, there are some conventions that you must follow when you are writing smart contracts. So back to the storage stuff. If you want to read storage value, you use the snapshot. If you want to write to storage, you must use the reference what? Keyword. Look at this now. We have the reference keyword. Two things here. If you are using reference keyword, you can as well read from state. Are you following? And also write to state. But if you are using snapshot, you can never write to state. In the body of the function, we first read the state. And then what did we do later on? We modify the state. When you are reading from Starknet storage state, you use the read keyword. Are you following? Yes, sir. You use the read keyword when you are reading. These are stuff that actually you need to read a whole lot of pages before they explain what is going on. You might be seeing them do read, write, read, write, read, write. But this is me telling you exactly what is going on. You read from that state or you write to the state. Another thing you must note is that when you are declaring your storage, you might declare storage and never be able to read and write if you do not bring certain stuff into scope. Just like, as well as something like, where is this again? Okay, I think by implication, declaring the storage here is already bringing our storage read pointer access, right, into scope, and write pointer access into scope. If you look at the explanation when I hovered over this storage, you see something like storage pointer write access on the screen, right? Sometimes you need to explicitly bring them into scope before you can read and write to storage. Are you following? You see storage pointer read access and storage pointer write access. One thing that you should also notice is that storage is not infinite. There is a limit to what you can have in storage. You understand, right? Every line in storage is a slot. In Solidity, advanced Solidity, they teach you something known as slot packing. Slot packing meaning that they do not want you to waste slots. Every Cairo slot is a FET 252. It's a 252 what? Bits. In Solidity, they will tell you if you are using U8, you are using 8 bits. That is 8 minus 252. You have 244 unused bits in that particular slot. Right? So when you see in Solidity, they arrange several U8, one after the other. They are trying to fit all of these U8 into one 252 slots. Are you following? So, but this slot now, each of these slots, that is 252 bits, we have number of what? 2 raised to power 251. Whatever that number is, it's large enough, right? But still, it doesn't mean it's infinite. So this means you can have as many storage as possible as long as you are within this particular range. I mentioned the other time why U256 is not ideal unless you are certain that you might be expecting numbers that should be close to that range. It's the fact that U256 is what? 256 what? Bits. A slot is what? 252. Meaning that you need 4 more bits to be able to use 256. So if you are using 256 as a value, you need 2 slots. I explained that day. So you can store custom types in storage once you have this external attribute in it. I've already talked about that. So once you are done with your storage, another part of smart contract that should be talked about, tutor assessment. Is this class more of theoretical or practical? Both. So we are combining both the theory and the practice, right? It's theory, right? So the practical means that what? We'll be writing. You will be practicing, and the tutor will be practicing. So that means I should tell you to open your VS Code, right? And code after me. I don't want it to be theoretical, but as you mentioned, you have to understand first. And actually, it is not theoretical, but because if it is going to be theoretical, I won't even show you how it is used in code. Are you following? I won't show you how it is used in code. For example, this is something I have done, and if I want to tell you, okay, oh, this is theory, all we'll just be doing is come here, read until the end of the line. Right? Without you seeing it in practice. The code I'm referencing is already on mainnet. So there's nothing more practical than that. You will practice. In fact, you must practice. And he has implicated you. You will do assignment. Nothing happened. You must do assignment. You don't want to do assignment before? How will you learn? How will you learn a concept if you don't build muscle memory by writing? So every line of storage value, for example, see balance, U256, right? We think this is a slot. But it is not a slot because the value we are expecting is what? 256. This particular line is what? 2 slots. Each slot is 252 bits. 256 is what? 256 bits. We need 4 more bits to be able to fit this 256 value. Now, the number of slots that we have, now here we know that we have what? 2 slots. Right? The total number of slots that we can have inside this storage struct is 2 raised to power 251. It's a very large number. That means from that very large number, we already minus 2 slots from it. Here, we have, this might not even be 1 slot because we are referencing another storage in a component. Are you following? This depends on how many values that they have in that particular component. Let me see if I can find open. So this is what the component we are using. Are you following? This particular component that we declared here, this storage, it has 2 storage items, ownable owner and ownable pending owner. These are just contract addresses, so they are basically within the range of fetch 252. You following, right? If you notice something, you look at the external attribute here, you are seeing Starknet component. I told you earlier on, you are going to learn component deep dive into component in a later class. This is what separates this particular contract. We can't even call it contract, this particular code from a Starknet smart contract. You might have written something like this with implementation and everything, but it's not deployable. You can't deploy this. This is meant to be reused in smart contracts. Did I answer your question?
Yes.
So we have function visibility, just like in Solidity. Function visibility, you already know it is mostly internal, external functions, right? For external functions, it can be called by anyone. Another contract can call your external function as well as the user of your contract. It must be defined in an interface, entry point. Are you following? The entry point. If you have an external function, it is not external function if it's not in an interface. Distributor. These are all functions that another smart contract can call on our contract, as well as the users of our smart contract. They can call our distribute function, distribute weighted, and what have you from our contract. Any other function that is not in this interface is not part of our external contract, external functions. Either it's an EPA function or an internal function. EPA function, internal function, they are the same. You must annotate the implementation of an external function with ABI embed v0. We'll write. In fact, maybe we should start writing. The only file you can see in this our source file is what? lib.cairo, meaning that everything inside this file is what inside this package is what is inside the lib.cairo. Are you following? Now look at this function, increase balance, right? We can decide, okay, in our own version, no, we don't want this to be here. You can say, okay, let's do hello.cairo hello.cairo. It is conventional to start all your interface file with what? I. Now we'll say, okay, no, we don't want you inside there anymore. You are our core contract. Come into the hello.cairo. You are not supposed to be here anymore. You are our interface. Come into hello.cairo. Now, what do we do here? Pop. Where is that man that said we are not doing practical? We've started practical now. So what do we do here? Pub mod hello, right? And what? Pub mod I
think it's only the hello. The hello file is using the. I think we reported the hello address on the hello file, so we don't need to.
Is that valid?
No, it's only the hello.
I wanted you to stand your ground.
It's only the hello that we use.
Okay, you said no, it's only the hello. No, it's not valid.
It's only the first one, line 2 there.
Why?
Because that interface is being used by the main hello file. So that is important to again.
So meaning that in hierarchy, we have the lib.cairo, hello.cairo, then hello.cairo. Why is it valid? It is valid, and you can as well not put it. You understand, right? You can as well not put it here. You are right. But it doesn't mean if you put it here, anything is going to happen to our contract. Are you following? You can as well not put it because it is part of our what? As long as we bring it into scope here. Use, what's the name of our Starknet contract, right? The easiest way is to use what? Traits. ILO. Correct, right? The functions.
It's gonna be functions.
At least. No, that's not the case here currently. We have a trait. The trait name is what? ILO Starknet. We import what's going on? You didn't specify the module? You said? Pub where? Our interface is already pub. Eh? What happens when we bring the the ILO back into the library file? Right?
Can you still put this same register it under
Can I say?
You can still register this pub there. So you don't need to put it here.
Inside the hello.cairo?
Yes. But if you register it here before you call it, I think it will work.
No. You can do that by actually declaring the module here. Then the module does not need to be imported. It's in scope. You just need the super keyword. For example, this is what you are saying, pub traits. Hello, right? Hello, Starknet. Right? You can do this too. It will be inside the code. But here, instead of create, you use what? Super. Is that okay? Now, what you need to understand here is that you have to actually bring the interface into scope with the words in the library file.
What if you had called this pub mob hello in the hello.cairo file? Wouldn't have worked.
If you had called
Pub mob hello, that is called that module in this file. The hello interface. If you call it at the top, where that code is, would it work fine?
no. The lib file is like our router, where all of us go back to connect to access other network, other computer on the system. You understand? Every of our files that we are connecting to that is outside of that particular file scope needs to be in the lib.cairo. Now, they can be nested. And once they are nested, you only need the top level file, you understand, to be in the lib.cairo. For example, you might be wondering that in our lib.cairo here, there's no I blah, 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 I this, blah, 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 but you can see interface there, right? So interface and all of these interfaces are what? Inside the interface file. This is the interface file. You can now see all our high whatever. Is that taken?
Yeah, so that means you don't necessarily have to put it in the left post.
We do not need to put all of this separately. This is actually you organizing your code. Instead of putting all of this separately inside the lib.cairo, we group them into in a folder and now expose that particular folder inside the lib.cairo. Are you following? Hello. Where did you branch from? Oh. We've branched for a long time. Where did you branch from? Before we started writing code, where were we? External functions, right? Okay, and I saying any of your external function that is not in an interface is not part of your code. This API generated. Get confused. This function, not external, once you deploy your contract, you will never see not external on the blockchain as part of the functions you can interact with. Simply because it's not what? It is not an external function. This function is internal. It's a local function. The only place this function is usable is inside what? Inside our contract. Is only applicable inside our contract. So our internal functions can serve two things. One, to modify states without actually exposing the implementation to the external contract. Look at this particular line of code. There is a particular internal function. Everything inside a generative trait, right? And where you actually specify that this is an internal implementation of an internal trait. Everything inside that particular code block is what? There's a slight difference that I want you to understand, right? If you have a code that is just no generative trait, no internal implementation, you can still use that particular code, but it is basically just pure function. You can't use that internal function to do what? To modify or read from states. If you have a calculation function, you can write just a function, but it's not going to be modifying or changing states. state modifying functions or state mutability. So you have two basically, just one state mutability, only the functions that can actually modify state. In our counter, contract, we have the balance, we have the increased balance. The increased balance can modify state simply because it is using what? The right keyword. And it's also using ref self as what? As a parameter. The other one, get balance, can only read from state. If we try to read to state here, let's say, okay, let balance equals to so self dot balance dot right is equal to balance plus 1. Return let new balance equals to self dot balance dot read. To new balance. So we've written code now, right? And we are trying to modify state inside the snapshot. What happened? It is telling us that we cannot modify the state of when we are having a snapshot. You do not have the real D. You cannot do anything here. This right keyword on line 22.
I'm talking about the error is showing when you
It is telling you method right could not be called on type, core, Starknet, blah, 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 candidate, this has not create implementation, context, blah, blah, blah.
So you said storage is immutable. So how are you writing and reading from the state?
We say storage is immutable.
Yeah, I think you are giving immutability, but we are writing and reading to the state.
Good. What did I say about when you are actually mutating a particular value in the last class? It is moved into what? Another slot, a separate pointer. Even though we've written the first value here, balance plus 1, or the original balance which is 0, is already in a slot. We are not modifying that slot or in the memory. We are only changing the slot to something else with the new value. The question you asked, well, from all this error message, which one is the error? You can see the method right. The method right is where you are getting the error from. And it does not have implementation of context, core storage base, and blah, blah, blah. It is basically telling you you cannot write to state, simply because what you have here is just a snapshot of the state, not the real deal. This is a view function. You just need the copy of the state. That's just what a view function is. Exactly.
Now, like take up the contract. Now, the function is balance. The right function. Alright. Confusing. says set the balance of right, and then bracket the balance of left. So is it right or is it just left?
Which one?
The function increase balance.
Increase balance. I said it earlier that once you have ref self, you can both read and write to states. You understand? You can read and write to and from states. So in the ref self, we have the ability to actually first, if we need to increase, but then we first need to get the value of what is inside it, right? Let's assume, okay, okay, look at it here. Instead of them, personally, I like explanatory code. Instead of doing this modification directly here, I'll first say, let's old balance equals to self dot balance dot read, and then old balance. Are you following?
Yes, sir.
So here we have access to both read and write to states. We will only be able to read if we are using snapshots, a copy of the states. But we will be able to read and write. But this is what actually tells you this is a view function. If you see function there, if you see a function declaration that has the snapshot stuff, it is telling you we are not writing anything to state here. It is a view function.
This function that we have here, is it internal or when you want to interact with it, or that you receive as a public function, or you have to use that generate before it's an internal?
No. This is an external function. Why is it an external function? It is because we are actually implementing what we said users can interact with from the interface hello Starknet. Are you following? So it's an external function, but it is a view function. This is an external function, but it is what? A write function. We can have a situation where a write function also returns a value. For example, let's say return fert 252. Alternate. Okay. Are you sure? Line 19. Okay. Okay, do you know why this error is coming like this? Why are we seeing this error? In the function signature, the function we are implementing currently, we do not have any return value. So if we want this to disappear, we go to the interface and change it to return fert 252. And then our problem gets solved. So the essence of most time, an interface is not only for the user, it's even for the developer himself. Because here, you already declare your function signature. So without you going out of what you said you are going to do when you get to the implementation, you have a guiding principle. The modification I just did there is to tell you that at a time, you can have a write function that returns value. It is not only the read function that can return value. But we already know that if it is because you want to fetch value that you are writing, you are wasting gas. If it is because you want to read value, just read value, don't want to modify state, you now make that function. You make that function writable function, right? You'll be wasting gas. Is that understood?
So it's not appropriate to return any value, or there is a case that you can return value.
There are cases where you return value. For example, when you expect your UI to instantly be updated once a function is called, you can return value. You following?
Yes, sir.
I mean, for this like this increased balance,
Yes.
is there cases that I can return value?
Yeah, there are cases you increase balance in the same function, you can get back the new balance after the increment.
Now, why not use events?
Why not use?
Events, or it's not possible?
No, it is possible. Once you do the state modification, you can use event, but that's another process entirely. Are you following? The event is emitted on the blockchain, not back to the caller. Are you following? Then you need to go and look at the index of the event, separate it, filter it, and look for the value you are looking for in the event. Are you following? Most time, the essence of having a return value for a write function is just for you to be able to update your state immediately, and then update your UI immediately. For example, there's something called stream, and you need a stream ID to be able to save that in your database, conventional database, not the blockchain database. So once you already create a stream, you return back the stream ID back to the back to the program that called the contract, and that can now be processed outside of the blockchain. But the scope of our talk here is that you can have a write function that returns value. So you already know that once you see an interface like this, you can differentiate which of them is a write function and which of them is a read function, right?
Yes, sir.
So here we have the contrast state, the ref self telling us this is a write function, and the snapshot telling us this is what? A read function. So external implementation, we already talked about how you can make your implementations external, right? No, we haven't. Now, going back to this code, we have the interface here. How do we now make the interface? How do we implement the interface? We can come and say, okay, yeah, nothing is going to happen here. Now, let's start the implementation. Say ABI embed v0. Right. Implement hello Starknet of hello Starknet. Traits. How do we do the traits? Where are we going from here? We need what? The curly braces. Is it curly braces we need? Not angular braces? Okay. Are we done? We have to implement. This is not correct. We need the states. So we do contract states, right? So what do we now need to implement? The function from the interface. The first function is what? Actually, once you over this, it will tell you the function that you need. We need what? Increase balance. So what do we need to do? Oh, English. So what do we need to do? Basically, all you need to do is, sometimes if you are lazy, come and copy the function signature. Now we have the function signature, we need to implement. Oh, you were saying semicolon? Why should we remove the T?
Because I think that is for interfaces. It's for interfaces, so that's remove the T from contract.
Another thing, yes, we need to remove the T. But the fact this one is actually telling us is that it is not in scope. We could have it in scope, but it doesn't mean our contract will work. It will not give you any squiggly line. But then you start debugging what is wrong with your contract. We can declare a pub trait T contract state here in this scope, and this squiggly line will disappear. Not to die. Oh God. The language server is too smart. It won't allow it to go. But you still notice that there is an error, but it's not the same error we were getting earlier on. You think? It is progress now. This squiggly line refused to go. What happened? Okay. What's going on? Why? Okay, same error. Okay, let's remove this. The error. Yeah, what's going on? Huh? Oh, I wish the language server would not be that smart. Because in our function signature, we say we are returning something, but we are not returning anything. This is supposed to be a valid function declaration, right?
Yes.
But it is now telling us there is an error somewhere.
Yes, sir.
And it is just because we are not returning anything. So we need to return something. We return R and then the error disappears. So meaning that the interface is just telling you what is possible. You do not have control over the implementation of the function. Even though the original code, this is not what they intend to do. They do not intend to have an increase balance that does nothing and a get balance that returns R. Are you following? So here now we say, okay, let's implement. Are you coding along with me?
Yes,
Is it increase or decrease? Increase. Increase. Increase or decrease? Increase. So now we've now implemented the increase balance. What about the get balance? We are done. This is actually the line that took me to writing the code. This implement block. Without this, you are not implementing the interface. You can call the name whatever you like, but the interface must be the exact name that you brought into scope. This hello Starknet. You can call this hello Starknet implementation. You can call this hello Starknet implementation. So you can call this hello Starknet implementation or Amala is Bay implementation. As long as what you are implementing as long as what you are implementing, we can't change this to hello stack N. It must be something, it must be an interface that is in scope. Are you following? We can have internal functions, right? Let's say we want to have an internal function. We'll come here and say generate traits. implement internal traits of internal implementation, blah, blah, blah. If we want to change state, what do we do? Contrast state. Okay. Myself. Where's my okay. This. Yeah, we can say function at rough solve contract state. Okay. Fetch 252. We'll just say all of this should be brought here. And then here, what do we do here? Hello? What do we do here now? We've moved all our addition implementation, the balance increment, right? We moved it into an internal function. So how do we now we can call this function only from the contracts. So how do we now call this function now? It is already in scope. Right? So the essence is that most time, and it is smart to do that, most of your implementations, like the implementation should be an internal function instead of external. You can do external, you can do all the implementation in the body of the increase balance. But it is smart to do the implementation in this particular order. Because down the line in your code, you may still need to do the same addition. What if you now have a function that says add and, let's say, why this squiggly line? It's not in our interface. Right? Now, here, instead of doing this addition, before we now do the subtraction, we just say self we already know this has done the addition already. and then we do the subtraction. We can still do the subtraction the same way we did the addition. Do you understand? So the essence of internal functions most time is that you can have similar computation elsewhere in the code. Instead of now duplicating your code, you already have the logic being done somewhere. Now we have referred to this internal function twice. First in increase balance, and then the second time in add and subtract function. Are you following? One of the things about internal function is that it is conventional, there will be no error if you do not preface it with underscore. But it is conventional to always preface your internal function with an underscore. So keep pure function outside of the implementation block. So if you have a pure function that is not doing anything to state, for example, this is a pure function. It is not doing anything to state. It is neither reading from states or reading to states. So this is just a function where we use for calculation. Increase the amount by 2. Whatever the user gives us, increase it, add 2 to it. It is a pure function, no modification to state. So for example, in our increase balance, we can say are you following? Do you get what I've done here now, right? We have the add function in scope, but it has nothing to do with the state. So it is just a calculation it is just doing a calculation for us. So implement multiple interfaces for better organization. You can have different interface. For example, we can come here and say we have another interface. Pub mod. number dot Cairo update I number to contrast state equals to function return number There are also conventions, especially when you have read and write functions. I love either if I'm writing to state, especially if it is something that is just directly manipulating the state. I like set. For example, if I have an admin, it's a contract address. If I want to change it, I like using set admin. Set number, let's say amount U8 get number returns U8. Let's create I number. So as outside of this implementation for the yellow Starknet interface, we can have another interface implementation. Say API embed v0 implement I number implementation of I number contract state Nobody told me that we have not actually made this what? A Starknet interface. The contract state. I'm doing the practical now, brother.
So how do you think of it? Why are we adding the T in interfaces and not in the contract implementation?
Yes, because in the contract in the interface is like a generic type. In the contract implementation, we need the actual contract states. The convention is just this T blah 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 here, right?
Yeah.
You can use anything.
Okay, those two differentiate.
No, wait. The convention, but I think it is enforced.
I know I can use the contract.
Well, with the contract, no complaint.
But it is convention that you use the contract state. But inside the contract implementation, you must use contract state. Are you following?
Are we using data apart from T or
In fact, we're trying to the contract state to not.
It will not work. So it is just whenever you see T, especially in all these typed languages, it is known as what? Generic type. It can be anything. So this is just to tell you that you can implement multiple interfaces in your smart contracts, just like we have done here. 2 different interfaces.
Sorry, sir. Can it mean like something like multiple, like a single, implementing like multiple interfaces, like I number for this one, then command this one? Is it possible? Not possible.
It is not. You mean you want to combine both of them, implement I number, contrast state, comma, ILO, Starknet, contrast state, comma. No, in the same implementation block.
Yes.
No.
But there's some languages that do that. So that's
An example of the language.
like
ASP.
Yes.
Okay. ASP, you can implement multiple traits, right?
Just like can
Funny thing is, I don't know ASP. You understand? I don't know ASP. But what this is similar to is like the inheritance in Solidity. You can inherit this contract is that contract, comma, this contract is this contract. But it is not actually the same thing. You understand? But in Cairo, you do different implementation of different interface. Are you following? Let's assume, okay, we want to try it. Let's go on and say, comma, which one? I number, right? I number. Can you see this now? Is it not what you are saying we should try?
yes, sir.
It won't work. So you can only do one implementation of an interface inside an implementation block. The good thing is that I thought I'll be feeling more sick by talking. Instead, I'm getting better. I was thinking I'll only use 1 hour, 30 minutes. Now we've already exhausted 2 hours. Let's go on. So event, somebody asked about event the other time. So what is the role of an event in a smart contract? From your experience of Solidity, what's the essence of an event in a smart contract?
Tell you that something has changed or something has been done without providing details.
The details of what happened or...
Yeah, what happened.
Yeah, that is close to it.
notification.
For the implementation of the function,
If it is a function is implemented, an event can be emitted to show that that function is called.
the most important usage of event in smart contract is for off-chain storage. Like when you say off-chain, it means that we are not storing this particular thing on the blockchain. We need it outside of the blockchain. For example, when you do transfer, right, and people want to be able to track what you have done, once you do transfer, the state will change. Only you will know. It will be in your wallet that your state have changed. You no longer have $10,000. You now have less than that. Only you would know. But how will you be accountable on the internet? How much the detail of that transfer will be emitted in an event that anyone can actually go and index and save in their database? From who to who, how much was sent? You understand? The typical notification, something has happened. So this thing has happened, this is what happened. For example, look at my example here, coming from our contract. Say, okay, the person that wants to stream your salary updated the per second rate. People should know, okay, yes, this has happened. They have updated the rates. This is what happened. What happened? What's the stream ID? What's the old rate? What's the new rate? And when was it updated? Are you following? This information is required if we are trying to actually now have blockchain as our single source of truth for the data we display on our UI. You know, you have two methods, basically. I'm telling you now holistically, if you start building a project on Starknet or any other blockchain, you can decide to do, once the transaction is successful, either accepted on layer 2, you already know the values that were used for that transaction, even from the UI, right, from your client side. You can decide to now update your database based on that value. But instead, that situation, it is not error-free. Because if you are not watching that transaction carefully, what if it is rejected on layer 1? Or what if it is even rejected on the layer 2 itself, and you have updated database? So you'll be having discrepancy. But the single source of truth is that if this transaction is completed, it will emit an event. So that event, the value from that event is now what you use to update your database. So that is the essence of an event. This is just how it is written. You declare the event external attribute. A whole lot of writing Cairo is a lot of abstractions. Because left to us, if they had let us do it, you need to write code telling the contracts, telling the Cairo or Starknet VM that this is an event. An event are basically enums that contain multiple types. Derive, in Rust, you already know when you have this external attribute. You have this attribute, derive, drop, sede, blah, blah, blah. You are telling the code that this code has this particular trait. This code, this enum, this event has the drop trait, meaning that once it goes out of scope, it is removed from the VM. Are you following? So this is how you... Each event type is a struct with a feed. Now, this is the event enums, right? These are the types. Convention. And this is not even only convention, it's idiomatic. You have to use the same name. It's key value pair too. Key value. So stream rate updated, stream rate updated. You have to use the same name for the event. The type, the value, they are the same. Now the implementation of the event itself. The event is a struct, not an enum, and it also needs to derive the drop and the Starknet.event attributes. Are you following? When you have this key attribute on a particular value or feed of the struct, it is telling you that you can actually query this event with this particular key or feed. So if we want to say, okay, now we want to save every of the event that has been emitted upon stream rate update, how do we do that? Or we want to fetch all of the changes that has been done to a particular stream. How do we do that? How do we fetch all the event from all the events that have been emitted in the contract? The unique ID. Once we loop through all of the events that has been emitted by that contract, we can always match which one was emitted that has this unique ID. That means we can have a table of rate changes. Are you following? So this is just like an index, a key that you use to search. So when you have this key, if you are declaring an event and you want the event to be indexed, meaning that it is easy to search, you need at least one of the feed of that event to be searchable. In our situation here, we are using stream ID, meaning that it is unique to every stream. So if the rate of a particular stream has been updated, we want to fetch all of the historical changes for that stream. If it was changed yesterday, emitted an event, changed today, emitted an event, and it's going to be changed tomorrow, we want to be able to fetch that all these changes match with this particular ID. I'm thinking of a real life example to explain this. Your record, let's say car record. You know, in advanced countries, when you paint a car to a new color, you update your motor vehicle record, right? Yeah. So if they check your plate number, your vehicle registration number, they will determine when they committed that crime yesterday, this car was what? Blue. Do you understand now, right? The color of the car is the key. Or it can be the make of the car. The registration number of the car is the key that they can use to track the color states of your vehicle. Here, we are using the stream ID to track the rate change of that particular stream. When we get to that part, you will learn it. But I will show you a glimpse of something I did in the past. This is actually you saying the UI part of your building a project on Starknet, which you eventually get to. But let me show you something I did some time ago to fetch. Here, this is me trying to fetch an event that is emitted from an event that is emitted from this particular transaction, this transaction here, that returns receipt, right? So the contract that I called past event, then I submitted the transaction receipt. Then I matched, if this event is equals to 0, right? Do this. Otherwise, return false. Transfer event not found. Here, I'm actually matching to an event, what will I call it? Will I call it event signature of what is emitted by Open Zeppelin ARC721 standard. Are you following? Look at the code here. Open Zeppelin token here, 721 component, and then transfer event. Are you following?
Yes, sir.
So, so once I decided that, okay, this particular event, this particular thing has this length of 0, I now went and indexed into it. The first index of that event emission, I called it what? Transfer event. Then fetch out token ID from that minting what? Transfer. Are you following?
Yes, sir.
This is basically this is basically me extracting out the token ID emitted once a minting function takes place on Open Zeppelin ARC 721. You know, minting on the ARC 721 Open Zeppelin is just basically transfer. It is transferring from address 0 to the recipient of the minting. So watch for the transfer event, extract out the token ID that was minted. Now use it offline. Are you following? There are several ways. No, I'm not sure, because I think this is the only way that I have found. There are other ways. I don't know, maybe we are going to do that. There are indexers that you can use, API barra, that you can use to index your smart contract events. I've never used it before. You understand, right? Yes, I've never used it before. Another thing I did here that I usually do if I do not want to suffer that much is that instead of waiting for events to be emitted, I wait for transaction to reach certain level before I continue code execution. Look at what I'm doing here. I was waiting for transaction to be accepted on layer 2. Once it is accepted on layer 2, I consider the transaction successful. So from there on, I continue my code execution. If I already know what the value of this token ID is going to be, I might not need to wait for the event, because I already know it is minted. The transaction is what? Successful on layer 2. Do you understand that now? Although probably when you get to UI implementation, you will be able to do justice to that.
Thank you, sir.
Oh, you said you've come across several times, right? So now I'm now getting tired. Once you declare an event in your smart contract, this stream rate updated is especially expecting, the event is expecting a type of stream rate updated. This is the type. stream ID, new rate, and old rate. Stream ID, old rate, new rate, update time. Are you following? Used to have break, right?
I think I did want to.
Is this getting too complicated?
Yes, sir.
Actually, it will be complicated. I don't know if I was supposed to go into details like this, right? But it is the first day. Do you expect to grab everything in a day? No. But then you started building familiarity, right?
Yes.
Because once you start learning this, once you start reading on your own or you start writing, you will know that it's not strange. You have seen it already. Even though it doesn't make total sense, not sense.
Now, will you drop the link to this?
Yes, I will. What about constructor? You already know what a constructor is now.
Yeah.
What does a constructor do? Called ones doing deployment, correct? Called ones.
It can also be used to set initial values.
It can be used to set initial value. You don't actually call it, oh. Do you know you don't call constructor? Yeah. You said? It is your VM that looks for the constructor. If it is present, it will execute it. So if you have initial states, if you have states in your contract that you want to set from the on deployment, you use constructor. Now, error handling is one important part of a contract. Number one is that, especially if it's the right function, it is going to cost you gas. You want to know if you want to validate your input, the arguments applied to your functions, early, before you run computations. If they are not what you are expecting, you want to protect against errors, right? Look at this function, distribute. We have a recipient, which should be what? An array of addresses. Let's assume somebody just sent one address to the contract and we started going, blah, blah, blah. We've initialized dispatcher, we get the contract, we done this. All of this is what? Consuming gas. Because you are doing computation. And on the long run, when you now want to distribute, you realize that it is not an array. Your gas will not be returned. Are you following? So you want to test immediately, assert that your inputs are what? Are correct. So if a recipient is empty, give us an error immediately. That's what? Empty recipient. Empty recipient is basically a constant. It's basically a constant. What's going on here? I shouldn't have wasted my time. I wanted to test if you guys remember what we did in my last class. I was wasting my time. So this is error handling. We validate early. You validate your input early, and then you also send back errors, like clearly defined error. If you look at this, if this is what you got when you call this function invalid recipient, you already know what this means. The person you are distributing to is what? Or the addresses are invalid. If you are sending nothing more than 0, we are not tolerating that. If you are sending 0 or less than it, -1, -2, you are on your own. We'll terminate execution immediately and tell you there is an error. The assert keyword is basically and majorly used for validation and error propagation too. And error propagation. Failed assertion reverts the transaction. It revert doesn't mean your gas is not gone. No. The transaction will not just be executed, but the computation that has been done before then. And one good thing is that for Starknet, you will not waste gas. Will anyone ask me why? Why? Because the VM will simulate your transaction before it sends it. If what you are sending is incorrect, it will immediately tell you without you even sending send. If you want to interact with this contract now, and you are not sending an array of addresses, in your Bravos or agent, you will be told. It will not even allow you to confirm. Is that smart or not? You see why, as a smart contract developer, you need this assertion so that you will not waste your users' gas. Validate their inputs. Are you following? You must validate their input immediately before you continue. Another one is access control. If you do not have access, if you start building real life projects and you are taking protocol fee, and anybody can modify your protocol fee address, you are gone. It means you also need to check, validate if it is a role-based function, only owner, just like in Solidity, right? Validate it on time before you send the transaction. If you want to break the contract, you will say, okay, you have the module, you have the import, you have the component initialization, you have the storage, you have event, constructor, internal functions, external functions, and that's all. Wow. That's so understandable. You can start writing, right? You can actually start writing. To be honest, you can start writing. You know, the best way to actually learn this is now assignment. You write a simple Cairo smart contract. Yeah, a simple smart contract. I'm thinking. What we usually do is student registry. I don't want student registry. Okay, I gave an example. I used an example in the last class. A supermarket that gives discounts based on the order. Right? You write a smart contract, a supermarket contract that gives discount based on the amount of order that a user places. So you can decide to use whatever value you need, you deem fit for the amount of order they need. That's just the contract. It's simple, right? So a supermarket contract, you give discount based on the order. And you need to consider that users that want to buy, we want to know what number do they need to order before they can get discounts. It is simple. That is just what? View function. Right? Yes. That is just a view function. I don't want to give you a job, but you simply basically just have a state that is what? Minimum order, which you initialize maybe upon your yes, don't worry. You do it any way you like. So the best practice whenever you are writing Cairo smart contracts, you should, if you need to, break down component functionalities into components and traits. You should implement proper access control and validation, just like I mentioned earlier. Okay, this is supermarket contract. There's access control there. There's access control. There's access control there. This supermarket contract. Use it. Gas efficiency. You don't understand? Yeah? You will do the assignment on your PC. Okay, I should send the question, right? Yes, no problem, I will do that. But basically, this user control, everything I'm telling you is me giving you expo. I'm supposed to just tell you to go and implement a supermarket contract and now grade you based on who did the best implementation. Emit event. Almost, not all, in fact, every state changing function, you should try to emit an event. If you are changing states, emit event. Because you definitely want to track the states outside of the smart contract. Documentation. You'll be working with other people. So make their life easy. For example, look at this interface. If a developer is just reading this code, they will go and say, okay, what does this function do? Distribute equal amount of tokens to multiple recipients. What do we need to do to actually do this? We need amount, the total amount to distribute. What about recipient? Is an array of addresses. You can go on and say an array of addresses to distribute to. That's more explanatory. Token, the ERC20 token to distribute. Now, merely reading this without looking at the implementation, you know what this distribute function is doing. Documentation is as important as the code. Testing. You are not yet there. I would have said you should write test for this supermarket contract. No. Not all, because you have not been taught components yet. Use best practices. And with that, the 2025 come to an end.